Good afternoon, everyone. I would first like to welcome each of you to our Loenbro webinar training series. Our goal with this series is to be an informative resource to our employees, business partners, and clients in regard to key industry topics. My name is Sabrina Coleman, and I will be your host for today's session. For those that do not know me, I am Loenbro Inspections Superintendent of our Integrity Management Department. Today's webinar is titled Understanding Radioactive and Hazardous Waste Generation and Management. We are proud to welcome Mr. Kurt Rhea with RAD Pros, who will be presenting today's webinar. Mr. Rhea has over 13 years of experience in this industry with practical hands-on experience in implementing hazardous waste oversight programs. We are very grateful to have Mr. Rhea and RAD Pros, who have been a valuable strategic partner of Loenbro since 2020. We hope that you will gain a solid foundational understanding of hazardous waste generation and management programs from this webinar. Please note that all participants are in listen-only mode for the duration of the webinar. If you have any questions that come to mind during the presentation, please enter them using the chat tab, and we will try to answer any questions at the conclusion of the presentation during our live Q&A session. Without further ado, I turn it over to Mr. Rhea.
Very good. Well, thank you so much for the gracious introduction and for putting this together, Sabrina. You and Loenbro are great strategic partners with us. We're proud to be associated with you in every regard. Thank you so much. Got just a quick disclaimer here that we'll let you take a look at. This presentation, you can read it yourselves, but this presentation is obviously limited in scope. We don't have a complete understanding of anyone's specific situations that they may be dealing with. And so today's presentation is meant to be general in nature. And as such, it's really an introduction. There's so much to know, especially in the hazardous waste and radioactive materials space, that we can't be held liable if you take specific things from here. There's just too many rules, too much to share. So again, this is really an introduction and not something that is intended to teach you how to do everything. So thanks so much. We'll jump right in. RAD Pros is, we're a diverse company. We offer both field services and consulting. We are very, very active in oil and gas, water treatment, mining, as well as with some manufacturers. We do a lot of remediation, reclamation work, hold radioactive materials licenses in multiple states, and do a lot of burn down and event management kind of work. You can imagine in the hazardous waste and radioactive waste spaces, there's a level of expertise that's required. We work a lot with waste transportation and brokering. We have relationships with multiple special waste facilities around the country. And as such, we broker a lot of waste. We provide a lot of regulatory consulting, training, environmental consulting, and dose modeling relative to radiation and risk assessments. So that's kind of who we are. I really want to just set that out there so that you have a feel for what our background is as we move forward. One of the biggest challenges that we have in the waste management arena is making sure that we do things the right way. We know there's tons and tons of rules available out there to us, not only local, but state and federal regulations. And there's a real challenge sometimes as we look at the cost of disposal that can pose some real challenges, not to mention we see a political climate out there and all kinds of propaganda, especially around event management, radioactive material, and hazardous material. You don't have to watch the news every night to see the train wrecks and the chemical spills, the issues around lead in water. There's so much out there. There's also corporate directives, sometimes people doing good things in corporations and sometimes people doing bad things in corporations. So it all starts with each of us taking responsibility for our own actions, growing in our knowledge and discernment and gaining wisdom as we deal with these special waste streams. And we have to be committed to that because there is going to be some blowback. And a lot of the things that we see in the news are propaganda that is not truly based on science. And so when we struggle with something, we let the science, we let data and analytical be our guide so that we're on solid footing. What are some of the waste streams that we're going to look at today from oil and gas and mining, water treatment, landfills and recyclers, manufacturers and production facilities? We're going to take you through a number of pictures so that you can take a look at where we see some of the radioactive and hazardous waste streams out there today. One of the things that we'll address early on here is something called naturally occurring radioactive material, or what's known as NORM. Naturally occurring radioactive material is all around us. We see it in very common places, such as in radon gas. Radon gas is radioactive. Radon is an isotope that decays over time. In fact, radon gas is the effluent of radium. As radium decays, it gives off radon gas. And with a half-life for radium-226 of 1,620 years, we have basically a perpetual source of radon gas that impacts all of us. And in fact, for the average US citizen, 37% of our exposure every year to radiation is from radon gas, simply from breathing. Not to mention the radioactivity in the soil, the cosmic radiation, and the exposure that we get from the medical community. When it comes to special waste, though, we have a term that's emerged in the US over the last few years, specifically around technologically enhanced, naturally occurring radioactive material, or what's abbreviated as TENORM. And that's comprised primarily of these four isotopes, radium-226, radium-228, lead-210, and polonium-210. And what happens is when we extract material from the ground, whether it's simply water for drinking water sources, groundwater sources, or it could be oil or natural gas. For example, when we extract these resources from the ground, we get radium, lead, and polonium that occurs naturally. And then when we go to process these materials, when we filter it, when we use clarifying tanks, things settle out and we end up with these concentrations of naturally occurring radioactive material. And so those specific waste streams are regulated in most states. And these concentrations of radioactivity break through regulatory thresholds, and then they have to be managed in a special way. And this is where licensing for radioactive materials management comes in, where typically the Department of Environmental Quality in your state will regulate these waste streams. And so let's look at some pictures from the oil and gas space. We see that there is sludge and equipment that can become impacted. And the matrix of the waste, whether it's a sludge, a liquid, a solid, or even equipment and debris, very much impacts how we sample and dispose of these waste streams. So your matrix is a key element in terms of waste management. Let's look at some other things, filters and clarifying tanks. Those filters, they capture the solids that they're supposed to capture through filtering and processing, and they become impacted not only with soils and sediment, but lots of times with radioactive materials. Here's some samples of piping and tubular, and you can see the scale that can build up. It's usually calcium and barium sulfates that concentrate or absorbed and attach to the pipe, and sometimes contained within those calcium deposits, you will find radioactivity, and that throws you into a special waste category, and now you can't just throw that pipe away. It has to be characterized and managed separately. This is a picture of a heater treater that's used to separate production water from oil, and the fire tube that's being pulled out of that heater treater is lots of times impacted with scale, and that scale typically has radioactivity in it. This is a recycling facility in the oil and gas sector, and it separates out production water from crude oil, and then through centrifuging and shakers and clarifying tanks, you end up with solids as well that then have to be landfilled. Of course, the crude oil can be recovered and marketed, and the production water gets re-injected in Class 2 wells. And it's basically returned about a mile deep from where it originally came from. This is a slide on a site that we remediated a couple of years ago. This fire was the result of a mechanical failure in a tank battery. And you're going to see a 400 barrel tank or 1,600 gallon tank launched like a rocket about 450 feet in the air here. That fire burned for 3 days, and we ended up taking 900 truckloads of material off this site before we were done with the remediation and then the reclamation and civil construction process. And when we have those catastrophic events, what's left behind, of course, is all kinds of charred debris. Most of the time, the facility will need to be completely demolished. The heat will melt tanks and disrupt the integrity of the entire infrastructure. The good news is that on a tank like this, you don't have to use confined space entry. So there's some benefits to that. But what happens here is that the fiberglass tank will actually burn right down to the sludge layer. And that heavy sludge will contain things like radium-226 and 228, sometimes at high concentrations into the tens of thousands of picocuries per gram. This is a view from the top of that site where you're looking down. The tan area is the containment area, the secondary containment where it's burned. But you can see within that all of the equipment and debris. The darkness is sludge and production water that's impacted the ground underneath. All of that would need to be excavated and remediated. You'd also have to deal with chlorides from the production water. So lots of special waste streams that are generated as a result of a catastrophic event like that. These are propane bullets, and they would contain things like propane or other natural gases, and contained within those gases is, of course, radon gas, which is chemically similar to these natural gases. As that radon decays, and it decays quickly in just 3 days, as that decays, it leaves a fine dusty film that ultimately needs to be cleaned out, and that fine dusty film is radioactive, again leading to lead-210 and polonium-210 impact. In the case of a downstream waste product like this would be in the refining process. You can end up with these heat exchanger bundles and the sludges that are accumulated. And this is where things get really, really complicated, because you can end up not only with radioactivity, class 7 radioactive material, but also D codes or K codes, other hazardous wastes that now have to be managed separately. And these mixed waste streams are especially problematic because you have both radiological and chemical constituents. And so it often leads to special treatment of the waste. Because of the radioactivity, you can no longer take it to an incineration facility. You have to separate and treat the waste first. Very, very complex. Same type of thing happens when you get inline inspection tools like you see on your left, or pigs, what's called pigs, that clean out these pipelines like you see in the bottom right-hand corner. So you get these heavy sludges that often contain various constituents, everything from mercury to hydrocarbons, all kinds of D codes, which I'll explain a little bit more later, as well as radioactive elements, especially in the form of lead-210 and polonium-210, which tend to be highly regulated. The same thing happens in the refining process and in maintenance. You see these pieces of equipment that become impacted with residuals as a result of processing. We don't think about it often, but building materials also contain radioactive material and can create some special waste challenges. So whether it's gypsum or whether it's the granite countertops in your kitchen, those can have low levels of radioactivity, as high as 27 picocuries per gram in the case of your kitchen countertops. When we look at drinking water systems, those are ion exchange columns on the left side and then a filter press on the right side. Ion exchange is just one of many treatment methodologies, including HMO, reverse osmosis, and green sand technologies that are used to filter out everything from turbidity or soils in the sludge. As well, they can be used with special media to filter out radionuclides or arsenic or other contaminants in drinking water. And we appreciate everybody's efforts in the drinking water space to try to make sure our water is safe to drink, but it also leads to some of these special waste streams. Paper and pulp processing, of course, generates its own waste, and we can see some radioactivity as well as sludges in that waste. Uranium mining, when we get into the fuel cycle stuff, we deal with all kinds of materials. Anybody with mining knows you've got overburden, in this case, weak uranium enriched waste rock that isn't going to be sufficient for the nuclear fuel process, subgrade ores, evaporation ponds and sludges, all kinds of issues. And then the radionuclides present, of course, include uranium, radium, thorium. We see some of these same things in rare earth mining, as well as in other metals mining and phosphates, all kinds of different waste streams. And frankly, it can be a very messy business. If you are involved in waste management, I don't have to tell you that waste is not always nicely packaged. The matrix is not always fun to deal with. You have muck boots and PPE and other contaminants that you have to be worried about, special conditions and PPE that need to be used, various containment methods. So one of our biggest challenges in waste management, of course, is proper storage and containment. So we take these piles of filters and we put them in nice bins. That's just what we do. And the bins are labeled. And so this is one of the things that we talk a lot about in waste management. Going back to these mixed waste streams that are especially problematic, fortunately, we don't see a lot of this in the water treatment space. You don't encounter a lot of mixed waste streams. It tends to be chemicals with SDSs. But when we get into oil and gas and some other energy sectors, mining, you end up with some very complex waste streams. And some of the issues that come up in that space with these mixed waste streams is that you don't have the E&P exemption. We could talk about that extensively, but basically when the RCRA rules were passed in 1976, there was a carve out for oil and gas, and any waste streams that were generated during the exploration and production process were exempted from the RCRA rules. But when we have mixed waste streams, we can lose that exemption. We also see limited gamma readings, so detection can become more difficult. We run into some sampling issues and some very expensive analytical costs. We can have more and more trouble finding landfills that can accept these wastes, as well as treating facilities. Our options really start narrowing, and as those things narrow, the price can go up significantly. I've seen drums of waste cost as much as $99,000 for a 55-gallon drum to be treated and disposed of. It can get very, very expensive. In the regulatory arena, I'm just going to touch on this, but all of the RCRA rules and the information on the federal side for hazardous waste is found in 40 CFR. In the radioactive space, the Code of Federal Regulations are under 10 CFR 20. And so if you're having trouble sleeping at night, I would recommend either of those sections of the Code of Federal Regulations, and you'll have a chance to get some good sleep that night. The RCRA program in general, though, is, again, it's a federal program, and it regulates hazardous waste that's generated from business, from cradle to grave, and I'll cover that in more detail in just a minute. So many states are managing hazardous waste programs in addition to the EPA, and then you have some stricter rules at various states versus the federal program. So states can regulate things more stringent than the EPA, but they do have to at least match the EPA standards. Now, the RCRA program covers these 4 basic areas: generation, storage, I said 4, I can't count today, generation, storage, treatment, transportation, and disposal. And so there's a number of these sections that it addresses. The good news about the RCRA program, if there's any real good news in it, is that it doesn't apply to households. So you and I don't have to spend too much time worrying about this in our own homes. What does cradle to grave really mean? It means that if you are the generator of waste, then you are going to be responsible through the entire process, from classification to on-site accumulation and storage to transportation, and ultimately for disposal or treatment. The real caveat here, though, is that once it hits the TSDRF at the bottom, you still have responsibility for that waste. So if that waste facility is not well run, you will still be responsible if the EPA comes in later on and declares it to be a Superfund site, and you'll still have financial liability. So this has some pretty broad implications in how we should approach waste management. How do we mitigate some of that risk? Well, the first thing we can do is limit the number of facilities that we take waste to. When you're a national company, there's a challenge, right? That you want to take your waste typically to the closest facility, but that can mean that you now have, in some cases, you have people that are taking waste to tens or even 100 different waste sites across the country. Well, your exposure is now spread around the country. You now need all of those operators to manage waste properly. So you want to use waste facilities that have great treatment, storage, and disposal facilities that typically have deep pockets, that they've been operating for a long period of time so that they have good history. And then the question you can ask yourself is, do they have other major clients? And so in some cases, it's super useful and beneficial in terms of mitigating long-term risk for you to use a facility that, for example, has a DOE or DOD waste management program. If they are a significant contributor to those things, then you've got less liability because they own a majority of the waste in the landfill. Do they have a good history of compliance? Have they been audited? Those are things that you ought to be asking. 2MEG is one of those entities that audits facilities specifically for waste compliance, and that's a good program. Have you properly characterized the waste? We are very aware of incidents that have happened at treating facilities and hazardous waste facilities where the generator did not properly characterize or label or profile the waste. And in some cases, especially where reactivity is an issue, then you can have an explosion at a waste facility and you could actually harm somebody else just because waste isn't properly characterized. So we have an obligation to properly characterize waste and then ensure that it's fully compliant in terms of both transport and disposal. And then again, if it's a hazardous waste or a RCRA waste in general, you've got reporting and record keeping requirements. So what are the major components of RCRA? First, there's a clear definition of hazardous wastes, including some specific waste exclusions. We're not going to go over all of those today. We don't have time to do that. But they define the technical and administrative requirements for generators, owners of disposal and treatment facilities, underground storage tanks, underground injection standards, and then administration of transporters of hazardous waste. And then it further defines recycle and reuse standards, land disposal restrictions, LDRs, permitting requirements for TSDFs, and then used oil management standards. So those are the major components of the RCRA program. And again, you can take a 40-hour class on that. So we are just going to hit the high levels today. So the first question we ask ourselves, is it a hazardous waste? And so according to the definitions outlined in RCRA, is it a hazardous waste? And how does a solid waste become a hazardous waste? Well, it specifically needs to exhibit one of four characteristics, and those are ignitability, corrosivity, reactivity, and toxicity. And so if it displays any of those characteristics, you have a hazardous waste. Further, then RCRA goes on to define 4 lists of waste. I'll show you just a little bit more about that. So these are listed wastes, wastes that are called out by name in one of these 4 lists. And then you can end up with a mixed waste that has a listed or characteristic hazardous waste involved, or it can be derived from a listed or characteristic hazardous waste, such as a cleanup of spills. If you have a listed or characteristic hazardous waste that spills on the ground, guess what? Even if it's mixed with soil or scoria, it's going to be now derived from one of these listed or characteristic wastes. So let's look at some of the D codes real briefly, and you can go through the full catalog of these. You can see how many are under toxicity, but we have ignitability, corrosivity, reactivity, and toxicity, and then the symbols that are associated with each. And then here are the 4 lists that I mentioned. There's non-specific and specific sources, and then there's U-listed toxic, discarded or unused chemical agents with us or sole active ingredients, and then P-listed, acutely toxic, discarded, unused commercial chemicals. So those are the listed wastes. And then briefly, I'll touch on this too. Again, we're in this RCRA space. So a generator needs to declare, a generator typically has an EPA ID, and they need to declare themselves based on their volume of waste, whether in that particular case they are a very small quantity generator, a small quantity generator, or a large quantity generator. And those classifications will define the timelines and management options and reporting requirements for those specific things. Again, we don't have time to go into all the details, but the next thing is then that we have to look at the accumulation quantity and time limits that vary based on these generator statuses. So there you go. Again, this is just an overview, but you can see that based on your generator status that you've got maximum accumulation amounts on site and how long can it stay on site. So those are all defined in the RCRA rules. Then of course we have labeling requirements, hazardous or non-hazardous, different types of waste, applicable waste codes and specific hazards, and then the accumulation start date is something that we would be focused on. How do we communicate when we have these hazards? The DOT has their own shipping classes. I don't have class 7 on there, but class 7 is radioactive material. You see these on tanker trucks all the time, these kinds of symbols. Then OSHA has their own set of symbols, and you can see those there, from environmental hazards to fire hazards to toxicity. And then, of course, the National Fire Protection Association has their chemical hazard labels. So it's not unusual to see these specifically on buildings. You'll see these color-coded numbers. Those mean something to firefighters. And then we have RCRA characteristics, ignitability. These are the D codes. So lots of times in the oil and gas space, we see ignitability and benzene, and those are specific D codes. Those end up on manifests, on hazardous waste manifests, and provide clear communication of hazards to all parties involved. When we label drums, of course, we want to label what type of waste we have. What's the description of the waste? What's the hazards that are presented? And when did we start accumulating it? The labeling is very, very important. Even if you properly characterize waste and then you leave it unlabeled, you still risk some exposure because remember, somebody else may walk up to that drum and not know what hazards are present. So proper labeling is absolutely critical to good waste management. Other waste management steps besides labeling, of course, waste determination is really in front of that. So pulling samples and doing proper characterization, storing waste properly. There are notification requirements to the EPA and tracking of the generator status. Regular inspections are required of the waste. Just because it was put into a facility, is it staying at that facility 30 days later? Those inventories are very important. Then shipping waste off-site within the time frame that's allotted, verifying that the shipment is actually complete, making sure you have your completed manifests and certificates of disposal, maintaining those records on site, and then there can be biennial reporting requirements to the EPA as well. Now, not all waste facilities are created equal. Waste acceptance criteria can be very, very different from facility to facility. You will also see variations by state and by facility about how many samples are required. In Colorado, for radioactive waste, you have to characterize it with 3 to 6 samples, or it's not properly characterized, and you have to use an SW846 calculator. There's analytical and data analysis requirements. Once we start taking something into a facility and we're getting quotes, we have to be aware of how they are pricing it to us. They may quote you $129 a ton. Well, what fees apply? An economic recovery charge might be 21% on top of those fees. They may have profile charges, manifest charges, fuel surcharges, free release survey charges, state, county, and compact fees, and local fees. So get the whole picture when you start costing out your waste disposal. Transportation requirements. Some transporters, depending on the waste stream, will have to have hazmat certified drivers. They've got to have that hazmat endorsement to be able to move, for example, radioactive or hazardous waste. You will find manifest scrutiny is a big deal at ports of entry, and even at disposal, you can have manifests that need particular scrutiny. They have to be prepared right, often by a certified radioactive materials shipper or hazardous waste shipper. So online profiling or scheduling, how do you get your waste profiled? What's the acceptance process? Every facility is different. What are the waste packaging requirements, either imposed by the landfill or imposed by regulation? And to navigate all this, there may be times where you just need help, whether it's from a broker or from the disposal facility themselves. Finally, in this disposal realm, can the facility perform? We're seeing more and more backlogs at facility. Are they a good operator? Do they have good technical staff? Do they have the capacity to take your waste? Can it be scheduled when you need it scheduled? We have run into some very serious problems during COVID and post-COVID, where there have been huge backlogs, especially in the incineration realm. So your time is valuable. What's the profiling and process look like? And in some cases with RCRA waste streams, your stopwatch is ticking. You know, you only have so long to get these things done. What are some things that you need to pay attention to? When we manage waste, our senses sometimes lie to us about a hazard. So we can't trust our eyes or our nose or things that we touch in the same way as we do in our everyday work lives. So when it comes to radioactivity, we've been on site after site where I've had people say, oh, this looks different. Do a survey of this. Let's go do some detection over here. That waste stream is totally different. We see radioactivity in all forms and shapes and matrices. So don't let your senses mislead you about what's actually present. Laboratories. Sometimes we'll recommend unnecessary tests. Make sure that you know what your targeted facility can accept in terms of waste based on what analytical. Sometimes proximity is not the best determinant in terms of where you should take your waste. What kind of challenges will you see in transportation? Availability, fuel surcharges, overweight permits, those are all things that are in play. DOT regulations, sometimes they conflict or are unclear. Don't wait till the last minute to prepare your BOL, hazardous waste manifest, or radioactive waste manifest, your NRC 540 or 541. RCRA regulations give you plenty to keep track of. And the last note I'd say is that dilution is not always a solution. In fact, in many, many cases, when it comes to RCRA waste or radioactive waste, there are specific prohibitions against dilution of a waste stream. So you need to be aware of that. Tips and tricks, things to do, plan ahead. Whenever possible, have a sampling and analysis plan, get your supplies ordered, get protocol for sampling communicated, have analytical pulled in advance whenever possible. It's not always possible in a turnaround situation or in particular in a catastrophic event. You can't always have analytical pulled in advance, but whenever possible, it'll help you move things along. Anticipate your disposal options because it can impact your analytical suite. Plan for storage on site if waste acceptance can't be established in advance. And then know your generator status and the resulting timeline implications. And finally, historical data can be extremely useful. If it's a waste stream that's created over and over again, it can really, really be helpful. In the in-field detection space, lots of times we have detection equipment available that can really send us in the right direction when it comes to managing waste. So it can help us get the right analytical the first time. It can narrow down our disposal options. And we just have to make sure that we use the right survey techniques or sample collection procedures in order to get the maximum benefit from these things. But you can have everything from a scintillator probe, as you see on the left side, or a pancake probe on the right side. Crude oil, when you're detecting alpha emitters and gamma emitters, the scintillator probe works just fine for crude oil waste streams. And then pancake probes are required because a scintillator probe can't detect lead-210 or polonium-210, for example. And then we can go into other detection equipment like PIDs, of course, gas, flame, benzene, chloride detectors. There's a host of detection equipment that's available, and all of that can help you with your waste management and waste characterization. We're going to get you into some of the more pragmatic stuff in just a few minutes. You'll be stick around because we do have some more suggestions for you. When we look at TSDFs, here's some of the things that are available to us. Of course, landfills have various classifications from MSWs to industrial waste to hazardous waste and special waste designations, in particular for oil and gas EMP exempt facilities. And then there are incinerators, commercial storage and treatment or consolidation facilities, recyclers of every kind, and then injection wells, class 1 for industrial waste and class 2, which is much more common For example, for production water, North Dakota has over 600 production water disposal facilities. That's a remarkable number of facilities supporting the oil and gas market. And then some of these facilities actually take TENORM, or low-level radioactive material. They slurry it up and inject it a mile deep where it can't impact other people. What do we see in some of the waste leaders? I'm not going to read these lists to you, but kind of ranked by biggest and baddest, from Waste Management to Republic and right on down the list. Those are some of the biggest waste management companies in the US. And then in the radioactive waste space, you see Republic and Clean Harbors and Secure Energy and Waste Control. Some of these folks, these are some of the leaders in waste management, especially special waste streams. One of the things that you all probably are familiar with is that just because we can measure something doesn't make it inherently dangerous. We have incredible laboratory methodologies and detection equipment anymore that really render some of these things, even though, again, we can measure it, it doesn't make it crazy hazardous. So I mentioned that radiation is all around us. We worry about radiation, and yet 50% of our exposure to radiation comes from medical uses. And I mentioned earlier that 37% comes from radon gas. So the average US citizen is getting 87% of their exposure from things that we really don't have tons of control over. In fact, it's really the elective medical stuff, the CAT scans, PET scans, those kinds of things that give us those high levels of exposure. Arsenic, we would all call dangerous, yet it's found naturally in some of our water. And the federal drinking water standard is 10 parts per billion. So if I have arsenic in my water, I may think that's a horrible thing, but if it's 1 or 2 parts per billion, guess what? We don't have to worry about a negative health impact from those things. And then we deal with the issues of imperial versus metric measurements, and that's its own world. It's really, I'll give you an example here in a second, but some of our thresholds, our regulatory thresholds, really start becoming quite arbitrary. In the international community, 1 becquerel of radiation, 1 becquerel per gram is considered radioactive material and something that we have to monitor for, and 1 is a good number. In the US, we use picocuries per gram, and 1 becquerel equals 27.3 picocuries per gram. But it's really interesting that 5 picocuries per gram of radium-226 and 228 in Colorado and North Dakota is considered material that needs to be regulated. And so what that says that in Colorado and North Dakota, we are 5 times more restrictive than the international community. And I think much of that just comes down to these units of measure. And so it's really, really interesting. Again, sometimes just because it's something we measure doesn't make it inherently dangerous. Well, sampling, how hard can it be? Maybe you've had some good and bad experiences with people who have taken samples before, but in many cases, representative sampling can involve compositing samples, again, being very careful to take equal aliquots throughout your waste stream, making sure that's properly composited before it's submitted to the lab. You can use Kalawasa tubes, you can pull multiple samples, and you're looking for indications of whether these multiple drums can be combined or can they not. How is it generated? So this sampling process and understanding how the waste is generated is critical to good analysis. And I won't go through this entire list, but these are all things that we have to consider in our sampling efforts and in our sampling and analysis plans. What are the methodologies? What tools are going to be needed? Are things labeled? Is refrigeration required? We have to pay attention to all of those things. If we're developing an actual sampling and analysis plan, then we want to make sure that we understand going in, what's our objective? Are we trying to satisfy regulators, or are we satisfying internal objectives? Who's going to review and approve the SAP? And these kinds of questions and their answers will determine the level of effort that your project actually demands. Then you get into QA/QC measures, validation of data, who's going to do the sampling and what kind of training do they need, what lab are we going to use, and again, how many samples are going to be taken. So you see a pretty typical RCRA set. If you look at the ICR, ignitability, corrosivity, reactivity, T-clip, metals, VOCs, SVOCs, reactive sulfides, cyanides, PCBs, and then in the radiochem space, you've got not only the TENORM radionuclides, but you also have thorium and uranium required by many facilities. If it's a liquid waste stream, you're going to need TDS or TSS or percent moisture. So we could spend a lot of time on that, but because of time limitations, we'll try to get you done here close to an hour in. So what's the regulatory climate like? We need to keep up with regulations. Are there new rules or guidance that's been published? Do you have a licensed contractor or consultant that can help you? Maybe you have an industry group that's helpful. What do your internal policies say, and do they conform with current state rules and regulations? Is it hazardous waste, and are you keeping track of the deadlines and reporting requirements? Are there differences between state and federal laws? All of these things can have an impact. In the case of radioactive waste, we have to be aware of whether we're moving licensed material across state boundaries. There are implications and rules from these compact regions. So it can get very, very complex. What's the world look like in waste management today? The good news is we do have more landfills and some with broader waste acceptance criteria than ever before. We seem to have more clarity in the rules and guidance these days, and that can be good. And again, as these things get sharpened and as limits are further constrained, it can be a challenge. The EPA has chosen not to promulgate TENORM rules at a federal level. I think that's overall a good thing. There's lots of recycling and recovery going on. We've got these niche treatment options available, and the RCRA disposal market in general is very stable. Things that are probably not so good, we're seeing increased analytical requirements, the incineration issues across the country, big backlogs going on there. Consolidation in the waste industry, that can be real challenging when you had good service from a smaller company and now they're part of a bigger entity and it's harder to get things done. Mixed waste is going to continue to be a problem. We have PFAS coming up, and I hear manganese in the water treatment space is right behind PFAS. So we've got some big issues with that. So more regulations, some with further reach. We've seen huge inflation in transportation and disposal costs, literally right around 20% across the board in transportation and disposal just in the last year. Then growing environmental activism, often without science or context. Again, I think that's a challenge for all of us. We're fighting publicity by and media and activist groups, often who are just not informed, frankly, about the issues. And so it's easy to get excited about things at an emotional level, but we need to look at the science. What are the opportunities to save money? We'll have this wrapped up here pretty quick. Velocity of management. The sooner we can get things properly managed, gosh, we can all move on to other things. And so getting waste properly characterized the first time, getting waste profiled faster, and getting waste acceptance done is huge. And then having the baseline of knowledge to know where the waste can ultimately go is really big. We don't have to spend all the time researching it. As somebody who takes large volumes of waste around the country, what we've seen is that we know facilities and their profiling processes very well. And in some cases, they have granted us a fast track because they know they can get good information from us the first time. And so our profiles get approved faster. Then the other thing that you can see is sometimes better rates at landfills and treating facilities. When you're using a waste broker, if they're the right waste broker, they can get you volume discounts. In some cases, we realize savings for clients and get them cheaper pricing than if they pursued it on their own. And so volume discounts can be huge. And using a waste broker doesn't always mean that you pay more for their service. Other opportunities to save time and money: want to optimize packaging. Look at transportation options, whether they're rail or private or LTL options. Sometimes milk runs can save you a small fortune in transportation. Regulatory compliance, getting it right the first time or paying up. And then there's inherent risk in a do-it-yourself mentality, right? Because it costs you time to do research and you're still taking the chance on whether you're doing it right. So we would suggest that the more complex the situation is, the more you be open to engaging some help in it. Make sure you're asking the right questions. Know when a licensed contractor is required. Understand that your relationship with regulators can impact how well your life goes, right? And so we maintain relationships with regulators to make sure that we can ask the right questions and get good answers and get their help instead of having an adversary on the regulatory front. Only engaging with companies with a strong safety and compliance culture. You want to do business with people who have strength. And ultimately, you want to protect you and your company from frivolous litigation and unnecessary violations through better documentation, educating employees on the context, risks, and exposure, and then performing audits of new entrants into the disposal and treatment arena. And that's what we have for you today. I hope that some of these practical tips especially were helpful to you. We also have on this final slide here contact information for Sabrina at Loenbro and for myself. We're sure glad to answer questions anytime, help in any way that we can.